So we're starting chapter 3. As a reminder, we got the midterm on Wednesday, so this is the recording. Hopefully you had, I can't give you more time. In fact, we are way behind what any other algebra class is doing. Every other algebra class is tested on chapter 2 at least a week ago, if not 2 weeks ago. I've given you more time than anybody else, I'm sure. But the show must go on. This next part in chapter 3 is not officially on the midterm. There is related content. So, like paying attention to this might actually help you on the midterm, even though I'm not testing on the questions in here. And that's only, that's like a pro tip. That's a secret I gave away. Kind of gave away part of the information, one of the questions. All right, so 3.1 is on quadratic functions and models. Hope Zoom doesn't go down again. That would suck. So quadratic functions are part of the polynomial functions group. And that's what chapter 3 is on. Chapter 3 in its entirety is on polynomials and rational functions. So polynomial is a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x to the n minus 2 dot 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 down to a1 x to the first power plus a0, which is a constant. A0 is really a0 times x to the 0, but x to the 0 is 1. This is just a subscript way of saying, like, quadratic goes up to n equals 2. F of x equals a sub 2 x squared plus a sub 1 x to the first power plus a sub 0. This is a general naming convention. For quadratics, we don't use the subscripts. We call them ax squared plus bx plus c, because we do them more than other polynomials. The only requirement for a quadratic here is a does not equal 0. A, B, and C are, or can be, complex numbers. We saw complex numbers, a plus bi. They're on your test. Now these are different a's and b's. Let me use x plus yi. Yeah, x plus yi. Not the same x's and y's, but at least it doesn't look like the a, b, and c up here. If that equals 0, this is a real number. We just have X, there's no I's. Now we can have a function as written in ax squared plus bx plus c form, or we can write it in a shifted format, a times x minus h squared plus k. This is similar. This is what we did in 2.7. In fact, I'm going to bring it up. From our lecture notes from 2.7, we had y equals f of x minus h plus k, and I specifically did a quadratic here with the h and the k. How to graph them. That might be handy to know. So how can we get between the two here? Well, going from option 1 to option 2, we can do complete the square. And we'll do it on a couple of the problems. There is a shortcut though. Shortcut, just spit out the results. The results are h equals negative b over 2a. And k equals f at negative b over 2a. Let's do an example. Let me give you a second to finish writing that. So let's take a look at f of x equals x squared plus 4x minus 4. So if I want to write it in the a times x minus h squared plus k. The a is the same. A here equals 1. Because a here is a is right there. Next, we'll take a look at h. H is negative b over 2a. B is 4. So negative 4 over 2 times 1. Negative 4 divided by 2 is negative 2. So f of x is going to be x minus negative 2 squared. And we can figure out k by plugging negative 2 into this function. F of negative 2 negative 2 squared plus 4 times 2 minus 4. Four plus 8 minus 4 is 8. Sums off, that's a negative 2. That makes that a minus. This is a minus 8. So if I clean up f of x, the minus minus turns into a plus. But my hk is negative 2 comma negative 8. So take the graph of y equals x squared. And shift the 0, 0 point to hk. So y equals x squared, I'm going to plot that. Remember, we've got the 0, 0, then the right one, up 1, right 2, up 4. And we do the same thing with the left. It's symmetrical. So I would have this for my y equals x squared. We're gonna do the same thing with this. Now we're gonna shift to negative 2, negative 8 though. Negative 2, then I go down 8, 1, 2, 3, 4, 5, 6, 7, 8. That's negative 2, negative 8. From there, we go right 1, up 1, and left 1, up 1. Right 2, up 4. Left 2, up 4. And we can use a little bit of symmetry. Hell, if we want to do it, we could go even further. Right 3, up 9. 2, 3, 4, 5 more over, puts a point right there. Another point right there. I think that red line should be a little bit to the left of it. That's f of x equals x squared plus 4x minus 4. Or f of x equals x plus 2 squared minus 8. We can confirm a couple things real quick. What is f of 0? By sticking 0 into this function up here, what do I get? Negative 4, right? All the x values go to 0. And look at that. We've got 0, negative 4 right there. How can I find out what these points are? My x-intercepts. That's my y-intercept. How can I find my x-intercepts? How did we do it in general in the past? What's true for the x-intercept? What does y equal here? 0. Y equals 0 here, right? Which is f of x. So we can find the x-intercepts by setting f of x equal to 0 and solving. I think this is a little bit easier in the x plus 2 squared minus 8 form. X plus 2 squared equals 8. We take the square root of both sides. We get x plus 2 equals plus or minus the square root of 8. So x equals negative 2 plus or minus, so this is 2 root 2. I got plus or minus written twice. Negative 2 plus 2 root 2 and negative 2 minus 2 root 2. So this value is 0.83, comma 0, just to the left of the 1 line. And this is negative 4.83. And as a little reminder, how do we complete the square to get to that? We should be able to get this by completing the square.
Or just give me, let me take a picture. There you go.
Completing the square without moving shit to the other side. Just remember, note we can't change the value. Anything we add, we have to subtract. So I'm gonna rewrite x squared plus 4x, and I'm gonna leave a little gap to complete the square. We've done this before. Take this number, cut it in half. That's what goes here. And then we square it. And that's what we add. So I added 4, I have to subtract 4 as well. So the x plus 2 squared, this is the x squared plus 4x plus 4. Realize that looked like a fraction. And then we have minus 8 left over. If it helps you, when you add the 4, you add the 4 here, you can technically add the 4 over here as well. That's the way we did completing the square in the past. But you don't want to end up with the 4 with the f of x. F of x needs to be by itself. So you subtract 4. And that middle part turns into the x plus 2 squared minus 8. Looking at the graph again, we can see that the domain is all real numbers. The range starts at -8 and goes to infinity along the y-axis. And we include the -8. And then they might ask you where it's increasing and decreasing. This very concept is as it goes from left to right. So it looks like it's increasing from here onward. That direction is increasing. And all the way up to that point, it's decreasing. So it's increasing from -2 to infinity. We don't include the -2 because it's not increasing or decreasing right there. And it's decreasing from a negative infinity to -2. Ready for another one? A little bit harder.
Wait. Yeah.
Still writing, so I'll slow my roll here. All right. Let's find the intercepts before we find the vertex. The y-intercept is when x equals 0. So we have f of 0 equals -15. We have the point 0, -15. X-intercept is when y equals 0. Or 4x squared minus 4x minus 15 equals 0. A times C is -16. B is -15. Oh, that's not true. B is -4. And A times C is -60. So if I want to find these, the best way to do it is to factor. Let's see, -60 and 1 is a long way away. We could do -15 and 4, that's -11, we're getting closer. -10 and 6 work. So pair them up. We can take out a 2x on this and leave behind 2x minus 5. We can take a 3 out of this and leave behind 2x minus 5. Pretty sure you have a problem like solving a quadratic equation on the midterm. So this is like reviewing for the midterm at the same time too. This turns into 2x minus 5 times 2x plus 3. Make sure you keep writing equals 0. All of this is important. Don't just drop shit off because you're lazy. You drop shit off because you're lazy, you're gonna lose points for being lazy. It's harder to read what you're doing, and it's not clear that you know what the hell you're doing. And I can't let you go on to be an engineer or some shit like that and kill people because you don't know how to write down if I can do mathematics. It's my job to stop that shit. So you saw we had 5 to both sides. We got 2x equals 5. Divided by 2, we got x equals 5 halves. Or you're going to get x equals -3 halves over here. This was when y equals 0. So we have 5 halves comma 0 and -3 halves comma 0. And that's 2.5 and that's -1.5. So the 3 points we have so far is 0, -15. We have 5 halves, which is 2.5 comma 0. And -1.5 comma 0. So this is going to look like a parabola opening upwards. All we really need at this point, if we get the vertex, we got enough. Which is at HK, we have enough. And the shortcut for those was H equals -B over 2A. And K equaled F of H, basically. So -B over 2A is -4 over 2 times 4, which looks like 1/2. F of 1/2 is 4 times 1/2 squared minus 4 times 1/2 minus 15. One half squared is 1/4. 4 times 1/2 is 2. This ends up being 1 minus 2 minus 15 is -16. At H equals 1, we've got a point at 1/2 -16. Right there. That 4 out front makes it really steep. This 4 right there makes it really steep. You can use a little symmetry to make another point right here. We had to go 1/2 this way. We went, well, from the vertex, you have to go 1/2 back to the left and up 1 to get to there. So you can do the same thing here. Go right 1/2, up 1, and you'll get 1,15 as another point right there. We'll do another problem that is a little easier to see. Notice I didn't do the 1,144. I could. The 1,124. I didn't need to do it. I could do it, and it'd be kind of lame doing it from here. Going right 1, up 1 from 1/2, it's gonna kind of suck.
I just have a question. Which one is the vertex?
Which one is what?
The point, the center point, how you call it? The vertex?
The vertex is the 1/2 -16. It's the HK.
Okay.
We have H here and we have K there.
Oh.
So for parabolas, a somewhat not too bad way to graph. A, find the intercepts. B, find the vertex. And then C, plot them using symmetry to help with points. All right, let me give you guys one to try. And we'll do it together in 10 minutes or so. Maybe 8 minutes. What's wrong, Jimmy? Pause it for 8 minutes. I'd love to give you guys more time. There are things that I'll show you guys things you can look at for extra video resources and stuff like that, in addition to what I've been teaching. For this, if we want f of 0 for the intercepts, we get -6. So 0, -6 is a point. I want to factor that. A times c is -12. B is 1. So 12 -1 doesn't work. 6 -2 is 4. 4 -3 is just a 1. So this will factor into 2x. Oops, let's not jump the gun here. 2x squared plus 4x minus 3x minus 6. And for this one, we're setting it equal to 0 for the x-intercept. We factor. This is, we've got a 2x times x plus 2 minus a 3 times x plus 2. So this is 2x minus 3 times x plus 2. When you solve these, you're going to get x equals 3/2 and x equals -2. So those are 2 more points. 3/2 comma 0 and -2 comma 0. I don't know how much more we need. I'll plot these. 0, -6 is way down here. -2 is here. And 3/2 is right there. Now, for this to have symmetry, the vertex needs to be in the middle of these 2 points. And since it's more to the right, it's further to the left over here than it is to the right over there, I'm guessing the vertex is just a little bit that way. Because this is 2 that way, and that's only 1.5 that way. So the vertex should be a little bit closer to like that side, but down near the bottom. We're going to find it now. Finding the vertex is h equals -b over 2a, which is -1 over 2 times 2 is -1/4. F of -1/4 is going to suck. This is 2 times 1/16 plus 1/4 minus 6. So this is 1/8 plus 1/4 minus 6. You get a common denominator. The 1/4 is 2/8. And we multiply 6 by 8 over 8. And we get -48 over 8. Which looks like -45 over 8. Or -5 5/8. Which is shitty. My vertex is at -1/4 -5 and 5/8.
First line of f of -1/4. Is it a -1/4?
That should be a negative, you're right. Which makes that a negative, which makes that a negative. Which makes that a negative. Which makes this -51. Nope, -49/8. And -49/8 is -6 and 1/8. Well, I just said that before I started graphing everything. Well, it would look funny as soon as I try to do 5 and 5/8. It would have said the vertex was above my y-intercept. That would have been a dead giveaway. As it is, 1/4 is really close to this fucking axis. And one down 1/8. Okay. Please jump in. Hopefully it lets me in. If you click on Video Resource Library in MyMathLab, you can pull up any chapter that you're wanting to look at stuff on. Chapter 3, we just did 3.1. I'd click Select All and do Find Now. And you'll see a lot of useful stuff. You can see some videos on doing some graphing of some parabolas. Solving a problem involving projectile motion. We'll look at an example of that. I don't know that I have one ready for today. We'll do it on. I'll make a video for it. We'll do it in class on next Monday. You can also open up the textbook if you don't want to skim through videos. And see worked out examples of stuff. So they're talking about the ax minus h squared plus k. They did it using the x and f of x. They did it by plotting points there. But pretty soon they shift to doing it like this. X minus h. They walk through how to complete the square. But they give you a torturous way of doing this. They show you how to complete the square to get h and k. Whereas you can just do h equals -b/2a. Do they not have that in here? Oh, there we go. H is -b/2a. And look at these shitty peoples. They put that as k. Oh, there we go. K equals f of h. And so you can look at other examples doing stuff that we've done in here. That can help supplement some of the stuff. We do have to cover the certain amount of material and we got to get it done. I'm sorry, I can't go slower. Does anyone want a break before we start 3.2?
Yes.
Let's take a 5-minute break. So, let's do an example. Like, what is the hell is this shit good for? A ball is thrown directly upward. from an initial height of 100 feet. There's no way this ball is throwing this speed with an initial velocity of 80 feet per second. If the height of the function, if the height of the ball follows normal, its height is S of t equals negative 16t squared plus v naught t plus s naught. Find the maximum height of the ball. So V naught is starting height or starting velocity. Sorry, it's V for a reason. And S naught is starting position or starting height. When you're throwing at an angle, like if you're playing catch with someone else with the baseball, there's some angles in it. You'll look at doing that in trigonometry in pre-calculus B, the next course. But this is just something that's going straight up, straight down. If we measure this as S of t in terms of t, S0 is the y-intercept. It's where it starts. And it's going to follow some trajectory like this. The ball is really going just straight up and then straight down. But if
He disconnected.
Okay, I thought it was me.
What happened? He
I think he-
disconnected. He disconnected, right?
Yeah.
Oh my god.
I just came back. All right, you guys will have to see the walkthrough on the paperwork when I scan it. We have started 3.2. We're doing synthetic division. We haven't actually started the synthetic division yet. This was how to divide a polynomial by hand. You do it just like regular division. Let's do what this chapter is on. I'm glad you guys were able to come back in by now. If you want to take a picture of this, please feel free to do so now this way. I know you're going to ask me as soon as I take this page away. Am I sharing the screen? I don't think I'm sharing the screen, am I?
No,
Don't say anything until I fucking comment, guys. You're gonna sit there watching me the whole goddamn time. There we go. Internet was down for a while. So this is doing long division with polynomials. I'm gonna do synthetic division with the exact same numbers. Exact same problem. What you do is you make a box and put the coefficients in the box. Bottom, you set equal to 0 and solve for x, we get 3. 3 goes outside. All right, so this is where synthetic division happens. You bring the first number down. That always happens no matter what. You take the 3, you multiply by the 4, and you put it in here. It's in that box.
-10.
That is a -10. Good call. And then we add -15 plus 12 is -3. And we keep doing this process. Multiply, put it in the box, add. Multiply, put it in the box, and add. So 3 times -3 is -9. I add and I get 2. 3 times 2 is 6. I add and I get -4. These are the coefficients of a polynomial 1 degree smaller. And that bad boy is the top of our remainder. So this was, we had x cubed. 1 degree smaller is x squared. So I will have a 4x squared minus 3x plus 2. And then I have plus our remainder, -4 over x minus 3. And look. And now what we got, doing it the long way? Synthetic division is a lot easier. Takes up less room. Where we're going with this, we're gonna do more with this on next Monday. But if I write this as, let's say f of x equals the 4x cubed minus 15x squared plus 11x minus 10. And so I had f of x over x minus 3 equals 4x squared minus 3x plus 2 plus -4 over x minus 3. This bit right here is called q of x as in reference to quotient x kind of thing. And this one is called Rx. Now, if I multiply through by x minus 3, just multiply both sides by x minus 3. I get 4x squared minus 3x plus 2 times x minus 3 plus -4 over x minus 3 times x minus 3. And if I write that in terms of q of x, this is f of x equals q of x times x minus 3 plus the remainder. Just the -4. That clears out and it's just the remainder. So that's usually what they call R of x, is the -4, not the x minus 3 part. And it's not always 3, let's just say it's like x minus k. And we get f of x equals q of x times x minus k plus R of x. If R of x equals 0, then f of x just equals q of x times x minus k. And if I set this equal to 0, it shows that it shows that x equals k is the solution. So this is called the remainder theorem. So f of x equals x minus k times q of x plus r. And so the remainder theorem is, if we divide by x minus k, the remainder is r of x over x minus k. We're gonna do more with this on Monday, the following Monday. I'll bring this stuff back up as a refresher. On Wednesday, we have the midterm. Class starts at 4. I'm in here from 3 to 4. If you guys have questions, like last minute questions you'd want to ask, come in and ask. Okay,
So we could come as early as 3?
yeah.
Alright.
I'll tell you what, I'll be here at 2. I'll be here at as early as 2. That way, because I don't think anyone's in here from 2. From 2 to 4, we can do all the last minute questions you want to ask. Stuff like that before the midterm. How's that sound? And that's a wrap.